Like, subscribe and press the bell icon for more videos from PHN Learn. For more videos, download our app from the Play Store.
In previous session, we have learned what are while loops and what are do while loops, right? In this session, we are going to learn what are for loops. Now, these for loops are very important factor of C programming languages, because in every competitive program also, in every competitive competitions also, you are going to get multiple choice questions related to these for loops only. Because there are various types how you can write these for loops, and these for loops are a bit confusion also. But if you don't want to create confusion, let's concentrate here. Okay. Now, in previous session we have seen that while loops are used when we don't know the number of iterations over there. When the number of iteration isn't specified, then we will use while loop. Right? But here in for loop, it's vice versa. When we know the number of iteration, then and then only we can use for loop. There we have to use for loop. In for loops, you know how many times the cycle is going to repeat, and that's where you are going to use for loop. Okay. Now let's see an example, a detailed example of this. We all know from our early ages, we know how the rain is formed. Let's revise it a bit. Now see, here you can see a scenario, right? There is one lake. Now what happens here is, when the sun comes and the rays of the sun falls on the lake, the water evaporates, right? And this process is known as evaporation. And later on, this vapors cools down and form small droplets. That process is known as condensation. And these droplets form a cloud. And when these droplets the cloud gets very busy by these droplets, and it doesn't have the space to accumulate these droplets anymore, what it does, due to gravitational force, these droplets falls, and that's how the rain is formed. Now see, the cloud is, oops, it's raining. Now, so this was the cycle how the rain is formed, right? Now imagine if there is something missing, like for example there is no water, then how will be the evaporation happen? And if evaporation will not happen, then how will the condensation process will happen, and so on. And what will be the result? There will be no rain, because the cycle has broken. Let's take and see an example of Sahara desert. There is no water, right? So there is no rain also. Why? Because if there is no water, that means the cycle, how the rain forms, it has broken already, and hence there is no formation, there is no output of that, right? Similarly, in for loop also, if the cycle goes on, if the condition is satisfied, the cycle goes on. Every condition is satisfied, then the cycle goes on. If the moment the condition gets false, the cycle breaks and the loop gets terminated, right? So this was how your for loop works. We have seen in while loop, after writing the statement, we used to increment the value, right? Similarly, here also, what we are doing directly in for loop only, while writing the condition and initialization, we are writing the increment or decrement value there itself. And don't forget to give semicolon in between. In for loop, if these three parameters are not separated by semicolon, then it will not have it. That means it is not a proper sentence of for loop, and hence you will get an error. So the semicolon over here is very important. Okay. Now let's see an example how this for loop works. So here I want to print all the prime numbers, like I have to take the input from user and I want to check if whether the number in which is given the input is prime number or not. Okay, so let's see here. See, this is my structure, basic structure of C. Now here I will initialize the value int num and then enter printf. I want to take the number from user, right? Enter the number. Okay. Then scanf %b comma %num. Okay. This was my 2 lines for how I can take the input from the user, right? Now let's check for. Let's say I. So firstly I have to initialize I over here also. Now see, if you want to take I globally, that is if you want to declare it globally, then it is also fine. And if you want that here itself you want to initialize it, then this syntax is also right. Directly here you can initialize it like this. I is equal to, let's say, 2. Here I have initialized the value there itself in the for syntax only. Then this is also right. Now for now I don't want to do this, so only I is equal to 2. Then I is less than or equal to num divided by 2 and then I plus plus increment. So this was my proper condition. Now we all know that for being a prime number there is a condition that the numbers which are divisible by itself and by 1, the numbers which are only and only divisible by itself and by 1, those numbers are known as prime numbers, right? So here what I am doing, I am writing a for loop. Now why I have not started with 1? Because we all know that 1 is divisible by itself. So 1 is separated. I want to check by 2, right? Because my prime number start from 2. 1 is not considered because we know the condition that 1 has to be if it is divisible by 1 or itself, and 1 is satisfying both the conditions. So we are not taking 1. Right? So I am initializing I is equal to 2 and then I is less than or equal to num divided by 2. Now why 2? Now for example I have taken 3. I have given user defined input as 3. Now I is equal to 2. Okay, I is less than or equal to num divided by 2, that is 3 divided by 2 I get 1.5, but I have given I is integer, so value will be an integer only, not float, right? So 1, but 1 is less than or equal to I, right? I is what? This condition is my false because I is greater than 1. I is my 2, right? So I is definitely greater than 1. So it will terminate the loop. It won't go inside the loop. Okay. Now here I have seen that if the number is getting prime, it is terminating the loop. 3 was my prime number, right? There what happened, it terminated the loop. It didn't go inside the loop because the condition wasn't satisfied. So now I want to write such a condition inside the for loop that it won't get prime number, because after completing the loop I am getting a prime number. So inside the loop I have to write such a condition that the number should not be printed as prime number. That means I have to write a condition of being not a prime number, right? So here let's say if n num is percent I is equal to 0, then printf, what here printf number is not a prime number. Okay, let's write flag is equal to here 1. Firstly initialize here flag. Then break. Now see here what I have done here, num mod I is equal to 0. That what does it mean? When num is divided, then the remainder should be equal to 0. When number is divided by I, then remainder should be 0. That means the number should be divisible by itself. If the number is divisible by itself, then I am getting 0, right? So if that condition, if the number is divided by itself, then that what does it mean? It's not a prime number. We have seen the condition, right? So therefore what I have printed there, number is not a prime number, because already I have seen that if anything is coming inside the loop, what does it mean? That it is not a prime number already. So I have to again recheck it and then I have to print a statement, that is, it is not a prime number. Okay, I want to recheck it first, and then if also satisfy the if condition, that means sure it is not a prime number, and if it is not, then break, then it will terminate the loop, for loop, and directly it will print afterwards whatever we will be going to write there. Okay, now why I have taken flag over there? Now firstly concentrate on that break. Now break is why? Because if the condition is satisfied, directly terminate the loop. So how will break will work? Firstly it will terminate the if loop, and then later on it will terminate the for loop, and then it will come out. Okay. Now here let's see why the flag is used. Okay, for that let's write the condition first. Now if the for loop is completely terminated, then what we were getting, the number is a prime number. So here I will write a condition as if flag is equal to 0, then printf number is a prime number. Okay, let's save it. Now see, initially you can see here I have declared flag is equal to 0. Now in the number is a prime numbers condition, I have given flag is equal to 0. Right, what happens here is, if the let's say the condition is going inside the if loop, which if loop? Which is inside the for loop, that is this condition, then those number will have the values of flag is equal to 1. But if the number is not satisfying this if loop, then it will terminate the for loop and will come out. That means from initially it was what was it having? Flag value as 0, because initially I have declared flag value is equal to 0, right? So therefore this flag, why I have written this flag variable? Because to bifurcate, to identify which numbers are my prime numbers and which are my not a prime number, right? See here again, if the number is going inside the if loop, that is which if loop? Which is nested inside the for loop. If it is going there, it will have the value of flag is equal to 1. But if it is not going there, that means initially startingly it was having flag value as flag is equal to 0. Then if it is having flag is equal to 0, then I know these numbers haven't satisfied the condition of if statement. That's why from initially only it is having flag value is equal to 0. So therefore directly I have written if flag value remains only 0, then it is a prime number. Right? So this is the logic why I have used a flag value. Okay. Now this is my complete code and let's run this code first. Okay. Now let's say 5 over here. See, 5 number is a prime number, right? So again, let's again run this code. Let's check for a different number. Let's say 22. See, 22 is my not a prime number, right? So this was my code of whether checking the number if the number is a prime number or not. Okay. So I will stop here for today. This was your today's session. Let's meet for the next session. Okay. Thank you and goodbye.
For more videos, download our app from the Play Store.